1.
Good morning everyone. Myself Lalitha. I am the Assistant Professor, Department of Electrical and Electronics Engineering, KPR Institute of Engineering and Technology. Today we are discussing about SCR. We already know the power electronics will be a control and conversion of electrical power using electronic devices. The electronic devices classified into diodes, thyristors and transistors. In that thyristor, the important one of the thyristor is SCR. First we start with expansion of SCR. The SCR expansion is silicon control rectifier. The rectifier will act as to convert AC to DC and it will act as a switch also. So like diode, we have the anode and cathode in SCR and the third terminal will be a gate. So it is a 3-terminal device, unidirectional device and current control device. The unidirectional means the current flow will be in one direction only. It is a current control device because the current only the main parameter to change all the reaction in the SCR. So it is a 3-terminal device. The terminals are anode, cathode and gate. It has 3 junctions, J1, J2 and J3. So 2 PN junctions are connected together to make a SCR. So it has 3 junctions and 3-terminal device. So we are giving the supply between the anode and cathode. So the junction J1 and J3 will react. So we want to react the J2 for the operation. So the gate terminal is connected in near the P type. So the gate supply is given to this through this terminal. The J2 will react. So this is the main concept of SCR. So the SCR is a semiconductor control rectifier. It is a 4-layer, 3-terminal and 3-junction solid state current control device. SCR is a unidirectional device that can conduct current only in one direction. So this is a simple structure and physical arrangement of SCR. So we have the 3 modes of operation in SCR. One is reverse blocking, that is off state, forward blocking or forward conduction mode. So first 2 are off state and third one is on state. We will see the reverse blocking mode. So this is the normal construction of SCR. We have 2 PN junction diodes and 3 junction. We are giving the supply between the anode and cathode. The P type is connected to negative and N type is connected to positive. So it is a reverse bias condition. In reverse bias condition, the depletion region width will be larger because there is no recombination of electrons and holes in this. So in reverse bias condition, J1 and J3 depletion region will be high. So there is no current flow between this PN type and this PN type. So totally this is the off state. The current flow will be very minimum in this case. That's why it is called as an reverse blocking state. We are giving the reverse bias supply between the anode and cathode and there is no supply in the gate. So there is no reaction in the junction J2. So the junction J1 and J3 depletion region width will be high. So the current will be very minimum. So this is off state. The second mode is forward blocking mode. The supply between the anode and cathode is forward bias. That means P type is connected to positive and N type is connected to negative. We already know the P type majority carriers are holes and minority carriers are electrons. So the holes will be attracted by the positive supply and in the N type the majority carriers are electrons and minority carriers are holes. So the electrons will be absorbed by electrons will be absorbed by the negative terminal. So the recombination will be happened in the P type is higher. So the depletion region width will be very small. The J1, J3 junction depletion region width will be very small. But there is no reaction in J2. So the current flow will be very minimum. We are giving the forward bias supply between anode and cathode. So it is called as an forward blocking mode. Still the SCR will be in off state. The third condition is forward conduction mode. The same forward bias condition. We are giving the forward bias supply between an anode and cathode. Now we are giving supply to the gate. We are giving the positive supply to the gate. So the J2 will be reacted. Already anode and cathode will be in forward bias. So J1, J3 depletion region width is very small. Likewise, we are breaking the J2 depletion region through giving the supply through the gate. So the J2 width also very minimum. Now we have the current flow between these two PN type. So the current flow will be higher and the SCR will be in on state. Once the pulse is given to the gate, then it will be removed, the SCR starts to conducting. So this is the process. The SCR have three modes of operation: reverse blocking, reverse conduction and forward conduction. So now in this case only the SCR will come from blocking state to conduction state. So once SCR starts conducting, the current flow from anode to cathode takes place. Also there is no need of gate pulse after turn on the thyristor. It has two current, one is latching current, another one is holding current. So latching current, holding current, both are minimum anode current. In latching current, it is a minimum anode current to initially turn on the thyristor. The holding current, it is the minimum anode current to maintain the conduction mode of the thyristor. This is the difference between latching and holding current. It plays a major role in this thyristor. That's why the SCR will be a current control device. The holding current is always lesser than the latching current. We have the different turn on methods. We already discussed the how to turn on the thyristor. So we are giving supply between anode and cathode, and the separate triggering will be given to the gate. So that is one process of turn on the thyristor. We have the 5 types of turn on methods. First one, forward voltage triggering, dV by dt triggering, that is the rate of rise of anode to cathode voltage is high. Third one is temperature triggering. Fourth one is light triggering. Fifth one is gate triggering. This is we discussed earlier. It is widely used method to trigger the SCR. So this is the voltage current characteristics of SCR. We already discussed the 3 modes of operation: forward blocking, forward conduction and reverse blocking state. So in forward blocking state, the current will be very minimum while we increasing the VAK, that is the voltage between anode and cathode. So while we are increasing the anode cathode voltage, the current will be very minimum only. Once the SCR gate triggered, then we can get the gate current, that is IG, then it will comes to higher. The anode current will be higher. So this is conduction state. This one is blocking state. In reverse blocking state, the same case, the anode and cathode voltage is reverse bias. There is no supply in gate. So the current will be very minimum, and once it will breakdown occurs, it will be comes down. So this is the voltage current characteristics of SCR. We have 2 characteristics in each and every devices. One is VI, another one is switching characteristics. Switching characteristics will explain each and every parameters. This is the anode current characteristics, anode voltage characteristics, current characteristics and leakage current characteristics. In VI characteristics, we have all the parameters in one characteristics. The same case, it will be explained in one by one in switching characteristics. So we discussed the turn on methods. In turn on methods, we have the turn on time period. We have 3 time periods in turn on: delay time, rise time, peak time. Up to 10% rise, it is called as a delay time. 10% to 90% rise is called as a rise time. 90 to peak value is called as a peak time. So T on time equal to TD plus TR plus TP. Likewise, we have turn off methods, because once the gate is triggered, there is no need to continue supply for the gate. So once it's triggered, the triggering pulse will be removed. So we want to separate turn off methods to turn off the thyristor. So the turn off methods are 2. One is reduce the anode current below the holding current. Another method is application of reverse voltage. So T of time period has 2 time period. One is reverse recovery time, another one is gate recovery time. So T of equal to T suffix RR plus TGR. We already, in last slide, we discussed about reverse recovery process to turn off the thyristor. So in reverse recovery process, we have the 4 time periods. It is the process to remove the excessive charge carrier in the junctions of SCR. We have 3 junctions, J1, J2, J3. First, we initiate the reverse recovery current in J1 and J3 to remove the excess charge carrier. At T1, it will happen. When we are reaching T2, the 60% of charge carriers removed from J1 and J3. In the next, J2 excessive charge carrier need to remove. So, at the time of T3, The reverse voltage across the SCR removes the excessive charge carrier. At the time of T4, the carriers are removed and the device moves to the forward blocking mode. Again it will be resetted. So this is the main concept of SCR. The same concept will be the triac also, but it is a bidirectional device. The disadvantage of SCR will overcome in the triac. In the next session we will see about the triac. Thank you.